Hello guys, here is another nested loop. Okay, so one may think we can just get the iterations of the I loop, then get it for the j loop. So we get it for the I loop, get it for the j loop, and then multiply the two iterations and then we'll get the answer. Well, that is completely wrong. Why? Because we cannot get the number of iteration of the j loop. Why? Because j loop is basically dependent on I loop here, j equals I. Based on each different value of I, the inner j loop will run different number of times. So you cannot assume that for each I it is running the same number of time. That is wrong. For each I it will run different number of times. Therefore, this logic of multiplying the iterations directly will not work. So what to do now? Well, we will have to calculate the total work done here. So we will have to calculate the total work. Basically, you can also do full length tracing also, but this is also okay. So how to do this? What we do is, we think for I is equal to 0, j loop will run from j is equal to 0, j less than n, j plus plus. So j loop basically runs from 0 to n minus 1. What is the work done? Work done is n iterations here, right? From 0 to n minus 1, total n iterations. Okay, then for I is equal to 1, j goes from 1 to n minus 1. So how many iterations? N minus 1. Since the previous one was n, so if you're starting from 1, that is 1 less, so n minus 1. For I is equal to 2, this will be starting from 2, because it is j is equal to I, right? So starting from 2, going up to n minus 1, giving us n minus 2 iterations. I is equal to 3, it will be 3 to n minus 1, giving us n minus 3 iterations. And this will keep on going until the last value of I, which is n minus 1. So when I is equal to n minus 1, j loop runs from n minus 1 to n minus 1. So only runs once. So 1. So to get the total work, we just need to add these. Okay. So it is basically n plus n minus 1 plus n minus 2 plus ... 3 plus 2 plus 1. This is the series, right? This is the same series here. I've written few extra terms just to make it clear. So now, what I know from this is that if I want to find the value of this series after addition, then it is difficult doing from this side, okay? It is difficult. So what I'll do it reverse. I'll do it from this side. So if I do it from this side, then this series becomes 1 plus 2 plus 3 plus 4 plus ... up to n minus 1 plus n. So this is basically sum of n natural numbers, which is equal to n multiplied by n plus 1 by 2, which is equal to n square plus n by 2. And this is the total number of iterations. That is it. This is the total number of iterations. What do? You put this inside big O notation. How? Ignore lower order terms, ignore constants, and put whatever is left inside big O notation. And this is the answer. That is it. Moving to the next problem now. Okay guys, so now problem number 2. This is a combination of for and a while loop. So we have a for loop and a while loop. So what we need to do is just understand what this code snippet is doing, and we will be able to figure out what the time complexity is. So if I look at just the while loop, then what is it doing? Just look at this part. If I just look at this part, then I see, okay, there is a j, and as long as this j is greater than 1, it is decrementing j. Okay, so this means that the while loop runs as long as j is greater than 0, and in each step, it is decrementing j by 1. So if j was initially 5, then while loop is basically this. J is greater than 0, j minus minus, which is equal to j is equal to j minus 1. So 5 will become 4, will become 3, will become 2, will become 1, and then it will become 0. So how many times will it run? For it will run for 5, 4, 3, 2, and 1. For j is equal to 0, this condition will become false, this will become false, and the loop will not run. So what I'm trying to say is, if j starts from 5, the while loop runs 5 times. If j starts from 10, while loop runs 10 times. If j starts from I, while loop runs I times. This is what I'm trying to say. Okay, so now let's find the total work done. So we want to find the total work done here. Okay, now let's do it. For I is equal to 0, J loop runs 0 times. For I is equal to 1, J loop runs 1 time. I is equal to 2, J loop runs 2 times. I is equal to 3, J loop runs 3 times. This keeps on going until the last value of I. Now, the condition for the I loop is I less than equal to power 2 comma n, which is equal to 2 to the power n. Okay. Now this is less than. This is not less than equal to. So less than. So what will be the last value of I? This last value will be 2 to the power n minus 1. So for the last value of I, which is 2 to the power n minus 1, the J loop runs 2 to the power n minus 1 times. Okay, so this is the total work done. So if I want to write the total work, it will be 0 plus 1 plus 2 plus 3 plus 4 plus dot 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 up to 2 to the power n minus 1. Now this series is simple sum of n natural terms. Now some people may get confused because of this. So let's say I am calling this k. So from 0, 1, 2, 3, 4, or you can say starting from 1, 0 does not matter. So 1, 2, 3, 4 up to k. It will be k into k plus 1 by 2. Simple. So for this, what you do, you just substitute the value of k here. So 2 to the power n minus 1 into 2 to the power n minus 1 plus 1. This gets cancelled. By 2 is there. So 2 to the power n into 2 to the power n becomes 2 to the power 2n minus 2 to the power n. This by 2. Now 2 to the power 2n can be written as 4 to the power n minus 2 to the power n by 2. I'm continuing this here. Okay. So this becomes 4 to the power n by 2 minus 2 to the power n by 2. Now when I take big O notation on this, lower order term constants go away. We are left with big O of 4 to the power n. And that is the answer. Okay. Simple. Always try to understand what the loops are doing, what the code is doing, and then try to figure out the total work. Okay. Now, based on I, J is changing. Based on J, the while loop runs. Hence, I'm finding the total work by choosing different values of I and figuring it out that based on this particular value of I, how many times is the J loop running. Whatever times the J loop runs, that is the work done for that value of I. And that way I will just add for different values and get the total work done. That's it. This is for problem number 2. Let's go to problem number 3 now. Okay guys, so this is problem number 3. Now this is a nested while loop. Okay, so you see there is an outer loop, this one, and then there is an inner loop, this one. Now, if we try to understand what the loop is doing, we will be able to figure out what the time complexity is. So what I see here is the outer loop variable is the I and the inner loop variable is this X. Now for outer loop, just thinking about outer loop now, I starts from 1, I is equal to 1. So I starts from 1 as long as I is less than n. Do this work and then do I plus plus. So in each step it is increasing I by 1. So I starts from 1, each step it is increasing by 1. And it goes up to n minus 1 because it is I less than n. So these are the valid values of I. Okay. So what I'm trying to say is that the outer loop is basically just very simple. It is basically just this for loop. Int I is equal to 1, I less than n, I plus plus. It is just this loop written in while format. Okay. Now if I look at the inner loop, this is just similar to the last question. The inner loop is there is this x which is equal to I, so x starts from I, and while x minus minus. Now this may get confusing for some people. Well, this is actually just same as writing this. While x is greater than 0, then you do your constant work, whatever it is, at the end do x minus minus. Or if this is also confusing, then x is equal to x minus 1. This is just exactly same. Why? Because this is post decrement. Post decrement. In post decrement, we first use the value, and at the end of that particular instruction, we decrement the value. So if the value of x is, let's say, 5, while this condition is checked, this 5 is used. And as soon as this condition check is over, that is, this particular line is done, before moving to the next line, this will be decreased to 4. Now this is part of basic programming. So if whatever programming language you use, JavaScript, C, C++, Python, Java, whatever it is, you must be knowing this post increment, post decrement, pre-increment, pre-decrement. So I'm assuming that you already know this. Okay. So considering that, now let's try to find out what is the total work done here. So it is actually very simple. It is just very similar to the last question that we saw. So for I is equal to, okay, it starts from 1. Okay. I is equal to 1. I is equal to 1. Condition is true. It goes inside. X is equal to 1. And then this loop basically runs x times. Right. So for I is equal to 1, it runs I times, which is 1 time. So this is the inner loop. For I is equal to 2, it will run 2 times. I is equal to 3, it will run 3 times. Keeps on going up to the last value of I, which is n minus 1. And for that, it will run n minus 1 times. So total work done is 1 plus 2 plus 3 ... up to n minus 1, which is, as you can guess, again, it is in the form, last value is n minus 1. So you're going from 1 to n minus 1. So there are n minus 1 into n minus 1 plus 1 by 2 is the total sum. Now this will cancel out and you are left with n square minus n by 2. If you do big O, you will be getting this. This is the answer. Big O of n square. Simple. Big O of n square. Okay. So important part in this one is, first you should know about post increment, post decrement, all those things. Okay. That is one. Second important is realizing the fact that it is just a simple for loop written in while format. Okay, some people have confusion between converting between for loops, while loops and do while loops. So this is an example of that. Okay. Now moving to the next question, which is the fourth question now. Okay guys, so this is the fourth problem. Now if you look at it, it is very similar to the first problem of today's video. So if you look at it, I is equal to 0, I less than n, I plus plus, and then there is j loop, j is equal to I, j less than n, j plus plus, j is dependent on I. So how I showed you in the first problem, what you do, for each I, you try to figure out how many times the j loop is going to run. So now let's see, for I is equal to 0, how many times is this j loop going to run? So if I just look at the for loop, then j will go from 0 to n minus 1, which is this. So work done in this case should be n, but that is wrong because of this break statement. What happens is, as soon as j is equal to 0, j less than n condition is true, it goes inside and the instruction is break. So this loop is broken, and then immediately I plus plus happens. I becomes 1. Okay, so what I'm going to trace it again just for the sake of understanding. Okay, what happens? I is equal to 0, I less than n is true, yes, goes inside, j becomes 0, then j less than n, true, goes inside, break. Immediately break, so j loop will be broken and the control is out of it. Now I becomes 1. I less than n, true, j will become 1, is 1 less than n, true, again break, I plus plus, directly, I becomes 2. So now you get the understanding that basically the j loop runs only once and in that it breaks. Okay, so for each value of I, j loop is running only once. So for I is equal to 0, now if I just try to write the total work done, j loop, for I is equal to 0, the j loop is running once. For I is equal to 1, it is running once. For I is equal to 2, it is running once. It will keep on going up to last value of I, which is n minus 1. For that also it will run once. Total work done is 1 plus 1 plus 1 plus 1. Keep on doing 1. How many times? from 0 to n minus 1, which is n times. So this is basically big O of n. Okay, so that is the time complexity. Because of this one break statement, the complexity went from n square to n. Okay, so this is the answer for this one. Now let's move to the problem number 5. Okay guys, so this is problem number 5. Again, a nested for loop. Now look at this one. So outer loop, there is outer I loop, inner j loop. J loop is doing only constant work. We have to find the time complexity. So try it yourself. Now, if I look at only the outer loop, I is equal to 1, I less than equal to power 3 comma n. So this is basically the programmatical way to write 3 to the power n. And at each step we are doing I is equal to I into 3. Okay, so basically you start from 1 and you're going up to 3 to the power n because there is equal to sign. Each step multiply by 3. So 1 into 3, 3 into 3, 9, 9 into 3, 27, 81. And this keeps on going. Okay, these are the valid values of I. If I look at the j loop starts from 1 and goes up to I. So again, this inner j loop is dependent on I. If I value is, let's say, 10, then j loop runs from 1 to 10. So work would be 10. If I value is, let's say, 1000, then j loop goes from 1 to 1000. This is j loop. This is work done. So 1 to 1000, 1000 iterations. Therefore, work done is 1000. Okay. Now let's try to figure it out. What is the total work done for this nested loop? Okay. I'll also erase this. Okay. So initially, I starts from 1. Okay. I value is 1. If I value is 1, then j will go from 1 to 1 because it starts from j is equal to 1. It goes up to I, j plus plus. What is the work done in this case? From 1 to 1, only one iteration. So work done is 1. Then I becomes 3 because j will go from 1. It does I is equal to I into 3. So 1 into 3, 3. Okay. So now j will go from 1 to 3. Total 3 iterations. Then I will become I is equal to I into 3. So 3 into 3, 9. So now j will go from 1 to 9, giving 9 iterations. Then 27. 9 into 3 is 27. So 1 to 27 will be 27 iterations. Then 81. 1 to 81. J will go from 1 to 81 since I value is 81. So from 1 to 81, there are 81 iterations. And this will keep going up to 3 to the power n. So when i's value is 3 to the power n, j is 1. J loop basically goes from 1 to 3 to the power n, giving us total 3 to the power n iterations. And this is the work. Now all we need to do is just add it up. So what is the addition? It is 1 plus 3 to the power 2. I'm writing in powers of 3. So 1 can be written as 3 to the power 0. 3 can be written as 3 to the power 1. 9 can be written as 3 to the power 2. 27 can be written as 3 to the power 3. Okay. Keep doing this up to 3 to the power n. Now if I want to find the sum of this particular series, what do I need to do? This is basically a GP. GP where a, that is the first term, is 3 to the power 0, which is 1. Common ratio r is just take any two adjacent terms, let's say this and this. So 3 to the power 3 divided by 3 to the power 2, giving us 3. So common ratio is 3. So I know the first term, I know the common ratio, and how many number of terms. Basically this series, how many terms are there in this series. So to get the number of terms in the series, just look at the power. That is why I wrote them in power of 3. Because the first term is 3 to the power 0, last term is 3 to the power n, and each term in between, there is just, the power is only increasing by 1. So it's 0 to n, there will be clearly n plus 1 terms. So number of terms is equal to n plus 1. Now I have a, I have r, I have number of terms. Formula of sum of GP is sum is equal to A into R to the power K minus 1 by R minus 1. A is the first term, R is the common ratio, K is the number of terms in the entire series. So I will just put it here. Where should I continue? I'll continue here. From here, I'm just putting it in the formula. So 1 into 3 to the power, number of terms is n plus 1. So n plus 1 minus 1 divided by 3 minus 1. This comes out to be 3 to the power n into 3, because this can be written as 3 to the power n into 3 to the power 1. Minus 1 by this can be written as 2. So this can be written as 3 into 3 to the power n minus 1 by 2. Now putting inside big O notation, ignore constants everywhere, and we are left with big O of 3 to the power n. And this is the answer to this particular iterative problem. So the answer is not n log n. Okay, common mistake. They think, okay, outer loop is going from 1 to 3 to the power n multiplying by 3 each time. So there are definitely log base 3 n plus 1 terms. And that is true. But you need to understand that for each of those log base 3 n terms, the j loop is also doing some work. So we need to count that also. And that comes out to be 3 to the power n. The total complete work is 3 to the power n, and that is the time complexity of this particular problem. That's it. See you in problem number 6. Okay guys, so this is problem number 6. Again, a nested loop. Now what we need to do is just go through it, try to understand what it is doing, and we'll be able to figure out what the time complexity is. So if I look at it, the outer loop is simple I is equal to 0, I less than equal to n, I plus plus. So there are total n plus 1 iterations here. Simple. If I look at the inner loop, I see that j loop is actually dependent on I. Not at one place, but actually at two places. It is dependent in the initialization part also, as well as in the condition part. So again, do the same thing. Just try to find the total work done. Okay, so for I is equal to 0, j loop, how many times will the j loop run? So j starts from 0, j is equal to 0, j less than equal to n, true, but then this is basically this condition, this entire condition has to be true, not just this part. And this is logical AND. So this part has to be true, as well as the second part has to be true. Only then it will enter the loop body. But the second condition, if you look at it, the condition is j greater than I. Now tell me, is it ever possible? Because in the initialization part, you are making j equal to I and then checking if j is greater than I. This is definitely a contradiction, direct contradiction, right? If j is equal to 10, then j can never be greater than 10 because it is equal to 10. And hence, this means the j loop does not run at all. So total work done for j for I is equal to 0 is 0. Okay, then let's go for I is equal to 1. I plus plus happens, I is equal to 1. So j becomes 1, j is equal to 1. Again, 1 is less than n, okay, fine. Second condition, j greater than I. Again, same thing, same contradiction. Because if j is equal to 1, according to the initialization, j cannot be greater than 1. This will always be false. Hence, this condition, entire condition is false. The j loop does not run. Work done is 0. Similarly, for 2, 3, 4, all the way up to n, j loop never runs, making j work always 0. Or I can say it is not 0 because you're still checking the conditions and initializing j. So it is actually not 0, sorry. It is constant work. It is not dependent on n at all. It is just some constant work. Whatever time it takes to do this and this condition check. Okay. So each time you are doing that only. And you're doing that n plus 1 times. So the complexity is big O of n plus 1. 1 is dropped. Complexity is big O of n. So remember one thing. Just because it is a nested loop does not have to be n square. Just because you see multiplications does not have to be log n. Okay. Always try to see what the loops are doing, what the program is actually doing. And based on that, try to derive what will be the time complexity. It will always be right. Okay. That is it. This was the last problem in this video. Thank you very much for watching. I hope you understood it. Thank you. Bye-bye.